Okay, so if you're in class, you know what I'm about to talk about. If you missed class, then you just missed us starting sort of the basics of stoichiometry. We won't get into stoichiometry until next week, but stoichiometry is just converting between compounds or between reactants and products. So we're given so many reactants in an equation, and we got so many products in the equation, and we may need to not necessarily predict the products like we've done before, but predict how much of the product is going to actually be made, or maybe how much of the reactant is needed in order to produce the amount of product that we need. Sort of like going to the grocery store and we know we want to make 5 cakes. So if we know we need 5 cakes, we can figure out how much of the ingredients we need, and then we can go and buy that number of ingredients. Or if I have set number of ingredients, I can then figure out how many cakes I'm going to be able to make. It's kind of like that with these equations. But before we get to stoichiometry, we're just going to start with the basics and learn how to use T-charts if we haven't used T-charts before. And it's really simple. All right, so the premise to the T-chart is we've got right here, this T-chart. We're going to start out with this two-piece T-chart, what we call two-piece. One piece is this side and the other piece is this side. We'll eventually work our way to multiple piece T-charts, 1, 2, 3, and 4 part T-charts. But for right now, we're keeping it simple. So just to kind of go over the basics of it, we're going to have numbers. And let's just say we have a 2 right here and maybe a 6 right here, and let's say a 3 right here. Well, the idea is whatever numbers are on top, we're going to multiply those numbers together. And then we will divide by whatever numbers on the bottom. So this big horizontal line right here is our division line. So we would say 2 times 6, which is 12, divided by 3 would equal 4. That's the math to it. So if you're really big on math, this will be really simple. If you're not really big on math, this is going to be really simple. Now, the T-chart is also set up to help us with our labels and canceling. We want to get our labels in the correct spot so that our numbers go in the correct spot. That way we know which ones we're actually multiplying and which ones we are dividing. The labels will cancel out so that we end up with the label we're trying to get to. So let's say, for instance, we were supposed to put a G right here for grams. Well, whatever I put here, I've got to put down here with label-wise. So I have to put a G right here for grams. And then I could go to mole for this example on top. Well, gram over gram, or gram divided by gram, means they cancel out, and it leaves us with mole. So then now we know our final answer will be 4 moles. So that's the idea of the T-chart. It's really simple. It's not a whole lot to have to write, but it is going to help us for when we finally make our way to the 3-piece T-chart, where we've got things here, 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 and then a 4-piece T-chart, where we've got things here and here, because we want to make sure we can cancel and we're multiplying and dividing the correct set of numbers. So you'll be using a T-chart. You're going to need to have a periodic table. Hopefully you've got yours. Otherwise, you can just pause this video and maybe take a look at these numbers. I don't know if this is going to be the best one for you, but maybe I can get it kind of close here for the meantime. And you can see these numbers. I don't know that it's going to really zoom in. Otherwise, go to ptable.com, maybe reference that one. Okay. So here's what we're going to do. Here's the worksheet we did in class. I'm going to work a few, and then maybe you can pause the video and you can work some. Once you work some, you'll notice at the very bottom of the worksheet is an answer bank. Now, these answers have been rounded to obey the scientific rounding rules, the sig fig rules or significant figure rules of rounding. I'm going to teach that next week. I've decided this time I'm just going to cut right into our baby steps of T-charts, and I'll teach the rounding rules later. So what you're going to do is you can solve these and then take your calculator answer, see if you can find the closest answer to it, and then use that answer to put into the blanks. And then I will teach you why we have some of these rounded the way they are next week. But here we go. This is the idea to the start of using T-charts and the start of converting. This stuff can be done when you convert inches to feet or meters to miles or just quarters to dollars, things like that. It's all dimensional analysis. It's just a matter of setting up a cancellation system and a conversion system to get to where you need to go. So here's what we're going to do. It's really easy. These word problems I have broken down and narrowed it down to just the basics. The question, in this case, how many moles, and what we have to work with. Number two, how many grams, and what we have to work with. So we're just alternating. How many moles, how many grams, how many moles, how many grams. So what we're going to do is we're going to take the only thing we know right now, number one, is that we have 15 grams of lithium. So we're going to take our 15.0 G of Li, 15 grams of lithium, and we're going to have that start our T-chart right here. Then we're going to get in the habit of taking whatever label, just the label first, whatever label we just put right here, we're going to copy it and we're going to paste it down to here. So now I have gram lithium down here. And then we're going to learn that mole, M-O-L-E, but M-O-L for short, is going to show up in all these ratios from here, like gram to mole ratio, or it could be mole to gram if it's switched around, or mole to atom, or mole to molecule. Somewhere we're going to have a molar ratio in there, so it's going to show up everywhere. So from grams on the bottom, we go to mole on top, mole of lithium. Now, if you remember, mole is just an amount of substance. Mole is just an amount of substance, or specifically Avogadro's number. Avogadro's number, which is 6.02 times 10 to the 23rd. So 1 mole represents an amount of substance, or an amount of an element, or an amount of something. But it's going to be more specifically the amount of 6.02 times 10 to the 23rd things, if you will. But the things could be atoms, molecules. So where a dozen represents 12 things, so a dozen eggs is 12 eggs, a dozen pencils, 12 pencils. A mole represents Avogadro's number of things. And we could say, if we were to, this 23 means we're going to move the decimal out 1, 2, 23 times. So that's really 602 and 21 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. All right, it's a really, really big number. It's actually 602 hexillion. So in 1 mole, there are 602 hexillion things. If I had 1 mole of eggs, I'd have 602 hexillion eggs. All right, it's a huge, huge number. On the microscopic world, it's very small, even though it's a huge number. Because if we're talking about atoms, 1 mole of an atom, like 1 mole of oxygen, there's going to be 602 hexillion atoms that make up oxygen. All right, so back to here, real quick. We start off 15 grams of lithium. We take our gram lithium, copy it, paste it down to the right, and then we go to mole. Whenever we see gram, that means we've got to go to the periodic table. So I go to my periodic table, I find lithium. Here's lithium right here. And this mass is 6.941. That means grams per mole. All these are grams per mole. So 6.941, I'll put that right here, 6.941 grams. And since on the periodic table it's grams per mole, that means we just have 1 mole every time. It's kind of like 55 miles per hour. I will travel 55 miles in 1 hour. Now, here comes the calculation. See, gram is over gram, so that cancels out, and it leaves me with mole, and that's really what I want. How many moles? So on the periodic table, since everything is per mole, we know that in 1 mole of lithium, there are 6.941 grams, basically 7 grams. Let's just say 7. So in 1 mole of lithium, there's 7 grams. The question wants to know, not in 7 grams, but in 15 grams, how many moles do we have? Well, for those that like to kind of look ahead in your head, if this was really 7, then 7 times 2 is 14. So that would be 2 moles. 1 mole is 7, 2 moles is 14, but we have 15. So it's got to be a little bit over 2 moles, right? All right, well, here's how we figured it out. We multiply everything on the top, 15 times 1. So that's 15. And then you divide by what's on the bottom. So really it's 15 divided by 6.941. So we asked the calculator, what is 15 divided by 6.941? And we see that it's going to equal 2.16 and change. Well, since we haven't been taught the rounding rules yet, you're going to have to take my word for it. We're going to have to look at the bottom of the paper, and we're going to have to see if we can find what is the closest to 2.16. And it looks like right here. So we'll take the 2.16. We'll put that right here in the answer blank. 2.16. And then we have, with our numbers, we have to have a label. Moles. How many moles? If you've forgotten the actual question, then you should see that gram is canceling gram and it's leaving us with mole. So 2.16 mole. Okay, easy enough. So in 1 mole, there's almost 7 grams. In 2.16 moles, there's 15 grams. It's just a conversion. Let's look at number 2. The only thing I know is I have 2.4 moles of sulfur. Run that right off of my T-chart, or run my T-chart right off of that. And then my teacher taught me that whatever label it has in the problem is the label I start with. And then I take that label and I copy it and I paste it down to the right. Mole sulfur. We're going to learn later on, once we get mole on the bottom, you notice the number 1 mole was on the top. But once we get mole on the bottom, we can go to any other label we really want to or need to. We could go to grams, we could go to atoms, we can go to molecules, we can even go to moles of another substance. But because right now we're keeping things simple, we're just going to go from mole of sulfur to grams of sulfur. All right, now we plug in our numbers. Since we have our labels in the right spot, our numbers should go in the right spot. We know that right now, if it's grams per mole, whether grams is on the bottom and mole on the top, or gram on the top and mole on the bottom, if it's grams per mole, we're just dealing with 1 mole. Grams then means go to the periodic table. So I go to the periodic table, I find sulfur, and I see that I've got 32.066. That means grams per mole of sulfur. 32.066. So I put that right there, 32.066. All right, easy enough. We know that in 1 mole, there's 32 grams. Question wants to know, well, how many grams is in 2.4 moles? So we're pretty much doubling our moles, which means we're going to double this for sure, but it's 2.4, so it'll be a little more than double. So if you're thinking ahead in your mind, all right, it's got to be a number greater than double 32. So let's just see. Now, instead of taking 15 or the top number and dividing by the bottom, we can just take the top times the top and divide by 1 in our heads. So let's take 2.4 times 32.066. That will equal 76.9584. So sure enough, if we double this, that will be 64, but we're really doubling it even more because of the 0.4, so 76.9584. Let's go to the bottom. We don't know the rounding rules yet, but let's see if there's anything close to 76.9584. Right there, 77. That'll work. All right, so 77 is our answer, and our label, grams. All right, maybe now go ahead and pause it and see if you can work number 3. Write the only thing you know, copy and paste your labels, and then either you multiply or divide based on the value from the periodic table. I'll go ahead and work number 3. You work it, see if you get the same answer as me. 22 grams of argon. Since I said grams, I need to put grams. So I copy gram, paste gram, and then I go to mole. Since I have mole on the top, that's where I'm going to put my 1. I should not put 1 on the bottom. It doesn't go in front of gram. Grams means go to the periodic table to find our mass. The mass should not go in front of mole. So as long as we have our labels in the right spot, we'll get our numbers in the correct spot. So argon. Argon over here, atomic number 18. It has a mass of 39.948. 39.948. All right, easy enough. So now, am I multiplying or am I dividing for the most part? I'm going to divide. I multiply what's on the top, but I can do that in my head, 22 times 1. So then I just need to ask my calculator, what is 22 divided by 39.948? 22 divided by 39.948. That equals 0.55 and change. All right, so we go to the very bottom. Answer bank, see if there's anything that looks like that. And yes, right here, 0.55. That would match our 0.55. Boy, that's great. Label, moles. Okay, sound good so far? Perfect. All right, so now I'm going to leave numbers 4, 5, 6, 7, and 8 up to you. You've got an answer bank at the bottom. If you aren't finding the answer bank to match your answer, then just double check and make sure that if you have gram here, you should cancel it with gram here. If you have mole on the top, you should cancel it with mole on the bottom. And if you have mole, you have 1. If mole's on the bottom, 1's on the bottom. If mole's on the top, 1 is on the top. Grams comes from the periodic table. Right now, I'm going to skip down to number 9. I'm going to do number 9 and number 10 with you. Just because they are dealing with compounds now, and compounds are just a little different than singular elements, right? So number 9, we got sodium fluoride. We got the name, I've got the formula. So let's start our T-chart, and then we can see what we do with that. I have 4.5 moles of NaF. Okay, run my T-chart right off of that. Now it said 4.5 moles, so I put 4.5 moles. And since I put mole, I'm going to copy it and paste it down here. From there, I can go to grams, NaF. All right, the easy part, what number goes in front of mole? That would be a 1. And then grams means go to the periodic table. But now we're going to go to the periodic table to find the mass of sodium, and we're going to find the mass of fluorine. So now we're getting more to this specific term called molar mass. Molar mass. It's a term we use when we just want to find the total mass of the whole compound. We could really say molar mass of one element. What is the molar mass of oxygen? Well, it'll be 15.999. But what is the molar mass of water? H2O. Okay, well, hydrogen is 1.008, and I have two of them, so it'll be times 2. And oxygen, there's just one of them, 15.999. So I would take this times 2, take that answer, add it to this answer, and I would have my molar mass. Easy enough, right? So let's look up sodium, Na, right there. Na has a molar mass of 22.990. So for sodium, 22.990. Then I look up fluorine. Fluorine has a mass of 18.998. So I'll take 18.998, and I just add those two together, so I'm getting my total mass. So that's an 8, that's an 8, that's a 9, that's a 1, that's a 4. 41.988. That goes right here. So we've been used to finding the mass of one element. Now we're finding the mass of all the elements in the compound and just adding them together. Then we could just solve the same way we've been doing. 4.5 times 41.988. Let's see what that is. 4.5 times 41.988. And that equals 188.946 grams, right? Because mole cancels mole, leaves us with gram. So let's see if there's anything at the bottom that rounds off of that. Probably this one right here, 190. 188 could round to 190. All right, so that's 190 grams. Perfect. I'll work one more, and then you can do the rest. Let's just look at number 10. It says I have 98.3 grams of AlOH 3 times aluminum hydroxide. So I'll take my grams, aluminum hydroxide, copy it, paste it. Gram AlOH3. And I'll go to mole on top. Well, how many moles am I dealing with? 1, because it's per mole. Grams means I need to go to the periodic table and put the mass there. Well, I've got this big compound now. So let's just, before we go to the map, let's see what we have right here. AlOH 3 times. Al, how many aluminums do I have? Just 1, right? All right, fair enough. Oxygen. How many oxygens do I have? I have 1 right there, but inside the parentheses, everything is triple. So 1 times 3. So I really have 3 oxygens. How many hydrogens do I have? 1 is triple. So I have 3 hydrogens. All right, so let's find our mass. Aluminum. Aluminum's right here, 26.982. 26.982. Fair enough. 26.982. There's just 1 of them. Oxygen. Oxygen is 15.999. And there's 3 of them. Hydrogen, 1.008. And we said there's 3 of them. So then you just calculate it all up the way you like to do best. You might want to use parentheses and kind of add as you multiply. It's up to you. So 1.008 times 3, I know that will be 3.024. And 15.999 times 3 will be 47.997. And then I add that to my aluminum. Add all 3 of those up. Let's see what we get. 26.92 plus 47.997 plus 3.024. That's going to equal 78.003 total grams, right? So now we know what goes here. 78.003. All right, now we just solve it the same way we've been doing. 98.3 times 1 divided by this. So in a grand total of 78.003 grams, that's how much is in 1 mole of the whole compound. 1 mole is 78 grams. Well, it wants to know how many moles are in 98 grams, 98.3. So we know it's got to be greater than 1, but it can't be more than 2 because 98 is not double 78. So let's see, 98.3 divided by 78.003. That gives us 1.26 and change. Well, right here is 1.26. All right, so 1.26 moles. So in 1 mole, there's 78 grams. In 1.26 moles, 1.25, barely, there's 98.3 grams. Okay? All right, so now you should be able to finish this page out. Keep in mind when you find the molar mass, make sure you know which subscripts go to who. Okay, this 3 tripled everything on the inside, so it tripled the O, tripled the H, but not the aluminum. This one here, how many berylliums do I have? Just 1. How many iodines do I have? 2. Down here, how many coppers do I have? 1. How many O's do I have? Well, they've been doubled. And the hydrogen's been doubled. All right, good. Okay, so that's that sheet. That's where we stopped in class. Then I handed out the second sheet. And as I'm looking here, I'm going to figure out what I do with another sheet because we need to practice just one thing that we practiced in class, and that was being able to enter scientific notation on your calculator or your calculation device. So let me see where I have my sheet. I'm pretty sure I brought it. Okay. Here we go. So here's what this sheet pretty much is. Okay. Let's do this part because I was already working this here. All right, so I already have T-chart templates for you. Okay. And this is numbers 1, 2, 3, 4, 5. 1 through 5, they're all grouped the same. The previous worksheet, it alternated, right? How many moles, how many grams? How many moles, how many grams? Well, this is kind of grouped. The first 5, it wants to know how many moles. So all 5 of them give us grams. We need to convert to mole. And I've got a sample one right here. The next 5, numbers 6, 7, 8, 9, 10, it wants to know how many grams, and it gives you all moles. Well, in class, we looked at number 10 and we looked at number 11 because we needed to practice putting in scientific notation into our calculator. So if you remember, Avogadro's number is 6.02 times 10 to the 23rd. Well, this times 10 is part of the scientific notation. If you have a calculator, mine has this EXP button on it. That EXP button is going to take the place of times 10. So if I wanted 6.02 times 10, I'd go 6.02 and I'd hit EXP, and then it's going to give me a little spot where I can put my exponent to the 23rd. Most calculators do not have an EXP button. They probably have what is known as a double E button. And let's pretend this is the calculator that does. If your calculator using a true calculator, not your phone, you might have a double E like on the face, or you might have a double E right down in here as a shift or a second function. So you hit second this button, and that would be double E. If you have an iPhone, at least the one nice thing about it is Let me go ahead and reduplicate. This was a rough draft worksheet where I had to make some corrections before I sort of printed off my new one. So it's got a lot of stuff on here. So I'm going to just redo the problem. 9.3 times 10 to the negative 3 moles of SMO. That's one of them. And then we have another one, which is 6.28 moles of aluminum. Okay, so if you have an iPhone, its stock calculator is super handy for scientific notation. All right, here's the phone. It's not mine, but I found it, so I'll use it. If we turn it sideways, we open up these other options, right? Well, it conveniently enough has this double E button on it. So that will be our times 10. Think of this double E as times 10. So we won't have to hit a times. We won't have to plug in a 10. That takes the place of times 10. So if I wanted to see Avogadro's number, the 6.02 times 10 to the 23rd, I would type in 6.02. That's this piece. And then the times 10 is the double E. So 6.02 double E. And then I type in 23. And then if I just wanted to see it, I can hit equals. I don't have to, but I will. And then the calculator, if it ever comes up with an answer that is a times 10 to something, it will just be a single lowercase e for this phone, for this calculator. So if I wanted 3.22 times 10 to the 2, then if I hit equals, it just moves the decimal over 2 times, 1, 2, and it just gives me a whole number. But if I'm ending up with a big times 10, like 6.3 times 10 to the 26, well, it's not going to expand that out, except I just hit it twice. It will not expand it out 26 times. All right, but I just hit the equals twice, so it went up. Now it's going too high. All right, so let's look at this one. This wants us to go to grams. So I'm going to run my T-chart right off of it. And this is mole of SMO. So I'm going to put mole SMO down here. I'm going to go to grams, SMO. Well, it's 1 mole. Grams, SM is 150.36. And oxygen is 15.999. So 15.999 plus 150.36 is going to equal 166.359. So in this one, I'm just going to multiply straight across. If you have the iPhone, if you have an Android, Android does not have the best calculator for scientific notation, but I'll show you what you can do. I won't be able to do it on this phone, but I can kind of walk you through it. Maybe you can envision what I'm saying. All right, well, let's solve this one. If you have this phone, this is what you would do. You type in 9.3, and then you hit the double E. So that's times 10. Then it's to the negative 3. So I got to go right here above the 8 and hit my negative sign. Type a 3. So now we don't really see it in the calculator, but we so far have put in 9.3 times 10 to the negative third. Check. Now we just need to say times 166.359. So I hit times 166.359. That equals, boom, 1.5 and change. Okay, well, on the back of our worksheet is an answer bank. And these are all rounded accordingly as well. So we would see right here, 1.5. Let me double check my problem. All right, so we're not seeing the corrected one because I've redone this part. So I want an answer that only has 2 sig figs. So we're really looking for 1.55. Okay, on your sheet, it's been adjusted. So just ignore this. This was an old style, but whatever. 1.5. That's what we want. That's what we got out of here, right? 1.5. Okay, so we feel good. If you're an Android user, just hang in there. I'm going to show you what to do in just a minute. Okay, let's look at this one real quick. This problem said how many atoms. All right, well, grams, if it says grams, that means the periodic table is where we go to get our value. If it says moles, it's a value of 1. If it says atoms or molecules, then we will use Avogadro's number. And the reason why we have two terms here is atoms. Atoms will be used when we're referring to just a single element, like aluminum. Molecules will be for a compound, like H2O. Either way, atoms, molecules, we use Avogadro's number. All right, so this one, it said we had 6.28 moles of aluminum. They want to know how many atoms are in aluminum. Well, we know everything on the periodic table. In 1 mole, it has 602 hexillion atoms, right? Because that's Avogadro's number. Well, we want to know how many atoms are in 6.28 moles, not just 1 mole, but 6.28. All right, so I run my T-chart off of that, no big deal. This says mole aluminum, so I copy and paste mole aluminum. And then I just go to atoms of aluminum. So I don't even have to go to the periodic table because I don't need the mass. I plug in my values. What goes in front of mole? 1. What goes in front of atoms? 6.02 times 10 to the 23rd. And then we just multiply. 6.28 times Avogadro's number. So on this calculator, I'm going to go 6.28 times Avogadro's number. 6.02 times 10 to the 23rd equals 3.78 and change e to the 24, meaning times 10 to the 24. Well, I'm looking here, and if you look on the answer bank on the bottom of your periodic table, on the bottom of your worksheet, you're going to see an answer choice that has 3 sig figs, which would be 3.78, and it will say times 10 to the 24th. All right. Now, if you have an Android, you're going to have to hit the little button so it allows you to turn it sideways. And after just looking at everybody's calculators, this is the best thing I can find. You have a button that is an x squared button. You're going to use that as part of your times 10. Okay, so you have to try to follow closely here. If you want to enter in scientific notation for Avogadro's number, you would type this in, 6.02, then you would actually hit times, and you would actually hit 10, and then you will hit that x squared button. What that will give you so far, it will give you something that looks like 6.02 times 10 raised to the, and then it'll be squared because you said x squared. Well, all you have to do is just erase the first parenthesis in this case, because we want Avogadro's number, which is times 10 to the 23rd. So you erase the first parenthesis and you just type in a 3. Now you have 6.02 times 10 raised to the 23rd. And then you just multiply that by 6.28, in this problem anyways, and you'll get your answer. If you wanted to type in something like this with your Android, you would just type 9.3. Actually hit the times, hit the 10, hit that x squared button. It then is going to look like 9.3 times 10 raised to the 2, correct? So we're going to erase the parenthesis and erase the 2, and we need to put in a negative 3. Well, you have, I can't remember if yours has it or not, compared to the Apple. It'll have something like this plus minus. I just can't remember right now if it's just a minus or plus minus. You will hit that. That's what's going to give you your negative symbol. Don't use a subtraction sign for a negative symbol. Okay, so 9.3 times 10, hit the little x squared button, delete the parentheses and the 2, hit the negative symbol, hit the 3, and then you're good. And then up here, we just took it times 166.359. You should get the same answer as we did, which was, maybe I didn't write that one down. Let me calculate it real quick. I thought I did, but 9.3 times 10, negative 3. 9.3 times 10 to negative 3. There we go. Times 166.359. Oh, yeah, it was the 1.5. So you should still get 1.5 for your final answer. All right. Okay. On this new worksheet, this is the old worksheet before I modified it, so it's got stuff all over it. But you only need to go to number 16. 16? Yes, only go to number 16. Okay, 1 through 16 on this sheet right here. All right. If that helps, if you have any questions, just text me or email me, and I'll help you. Otherwise, I'll see you in class. All right.